So due to phone call I am able to pause that video. Now we will discuss about what is strain. So as we discussed now, it is a stress due to the external force per unit area applied by against the resistance. It is known as the stress, whereas the strain is what? Strain is totally different from the stress. So what is how we can define the strain? Strain is defined as the change of dimensions of the body. So strain deals with the change in the dimensions of the body. It is defined as the change of dimensions of the body to the original dimensions of the body where body is subjected to external force. So how we can define the strain? So when you apply external force on the body, there is a change in the original dimensions of the body. So the strain is equal to change in dimensions divided by original dimension. And mainly important thing here, why the here I written strain is dimensionless. Why strain is dimensionless? I will explain here. So change in dimension is also in mm, and change in dimension is also in mm, and here the original dimension is also in mm. So this will get cancelled. So strain is a dimensionless quantity. So like this you can understand the strain. So let's we will see different types of strain. What are the different types of strain? Once again here same: tensile strain, compressive strain, volumetric strain and shear strain. So already three types of stresses we discussed: tensile, compressive and shear. And here another will come volumetric strain. It is strain. Okay, tensile strain, compressive strain, volumetric strain and shear strain. What is tensile strain? Once again it is here same. So whenever you take on rectangular block and you are applying a tensile force, due to that what happens? There is a change in original dimensions of the body because of two equal and opposite pull. What happens here? This is the original length and this is the, what happens here? I'll write like this: delta L, or we can write it as a dl. So what is this? This is change in length after applying the external force, whereas this is what? Original length. So dl upon L is known as the tensile strain. So it's very easily you can understand. So here it is written strain is denoted by the small e. So Et is equal to LF minus L0. LF means what? Final length minus original length upon original length. It is known as tensile strain. Then what comes? Compressive strain. So compressive strain is what? It is defined as a ratio of decrease in length of the body to its original length when subjected to compressive force. So here we will discuss about what is compressive strain. So compressive strain is defined as the ratio of decrease in length. So when you take a rectangular block and you are applying just a minute, take rectangular block and you are applying two equal and opposite push, therefore it is push. When you apply two equal and opposite push, what will happen? You take example, best example is sponge. When you apply compressive force, what will happen? So it will get compressed. Due to compress, what happens? Length will decrease. This is the original length, LO. I'll write it as LO, and this is what? LF. What happens? This is L0, LO and LF. LO means original length, LF means final length. Length will decrease, whereas main important thing, the cross sectional area will increase. This is known as what? Compressive stress. So what is this? Decrease in length. So this is the formula: decrease in length upon original length. Decrease in length is what? dl upon L. Okay, so compressive strain is equal to LO minus LF upon LO. So here you can do the comparison between the tensile stress and compressive strain. Tensile strain and compressive strain. So in the tensile strain, you can see here LF minus LO is there. Means length will increase, whereas here LO minus LFO means original length minus final length. Okay, means original length is higher here and final length is less here, whereas in this, and whereas in the tensile what will happen, final length is more and original length is less. Okay, so this is the major difference between the tensile strain and the compressive strain. If you read the definition, you understand clearly. Okay, so like this you can explain the both the strain. Next comes volumetric strain. So it is defined as the ratio of change in volume of the body to the original volume. So it is very easy. So whenever you apply external force on the body, so there is change in the volume of the body. So change in the volume of the body to the original volume it is called volumetric strain. Now here we can discuss about volumetric strain is equal to change in volume upon original volume. What is this? Change in volume upon original volume, dV upon V. What is shear strain? Shear strain is equal to, it is defined as a strain produced to the corresponding shear stress due to the tangential forces acting across the section. It is denoted by the tau. So what is this? Defined as the strain produced due to corresponding shear stress. So because of the shear stress, shear strain is formed. What is the shear stress? When there are two equal and opposite forces acting tangentially across the resisting section is known as the shear stress. So when this shear stress causes corresponding to the shear strain, it is called the shear strain. Okay, so tangential forces acting across the section. Now next we will discuss about, you already studied this term in the science also, Young's modulus. Young's modulus experiment you have done, I think. So what is the Young's modulus? It is defined as the ratio of tensile stress upon tensile strain or stress upon strain. It is defined as the ratio of stress upon strain within the elastic limit. So this experiment, when you are conducting, you are remembering this this one. So when the spring is there, for that you are applying the different weight. Okay, so and you are floating the curve in the, okay. So here what happens, whenever you are applying a load within the elastic limit and external force is removed, it will come back to original shape and size. It is called elasticity. Okay, but here what is Young's modulus? Young's modulus is defined as the, when the material is loaded within the elastic limit. So within that elastic limit, just what I explained, within the elastic limit, the stress is directly proportional to strain, is known as the Hooke's law. Next point is Hooke's law. It states that when a material is loaded within the elastic limit, the stress is proportional to strain, is known as the Hooke's law. So Young's modulus is also known as modulus of elasticity. In exam they may ask sometimes, explain the modulus of elasticity, or they will explain, they will ask to explain the Hooke's law. Both are almost same. So in the next class we will discuss about the next topics. So I think today this much is the enough. So but you people have to write this in the notes book and mail it to me, and you fill the attendance. Okay, and any difficulty is there, so you can type message in my personal WhatsApp number. So I will correct my video for as per your comfort or the requirement.